Algebra 1, Lesson 29, solving literal equations. So we want to recall that when solving an equation with one variable, inverse operations are used to isolate the variable as shown below. Right? Not dissimilar from what we just did, some of the questions that we worked on from your last homework assignment. Right? If we have 2x minus 6 equals 14, we're going to add 6 to both sides to undo the subtraction. We would call that the addition property of equality. Right? We're going to simplify that down to 2x equals 20. We're going to divide by 2. We're going to use the division property of equality. We're going to use that division to undo the multiplication where we have 2 times x. Now we're dividing. And then we're going to get x equals 10, which is simplification. And all that's pretty easy. Okay? A literal equation is an equation with more than one variable. For instance, all of your linear equations include an x and a y. They may use other variables, but essentially an x and a y. As in an equation with one variable, we would still use inverse operations and properties of equalities to solve for a specific variable. And we'll do some typo fixing here. In a literal equation, the solution for the specific variable will be in the terms of the other variables and numbers. So if the variable being solved for is on both sides of the equation, the first step is to eliminate the variable on one side or the other. Just like the question that we just had up there. We had an x on both sides. We had either the option to move the 2x over with the 6x or move the 6x over to the 2x. That has to be done. We've got to get that variable together, combined into one spot. A formula is a type of literal equation. We use inverse operations to isolate any variable in the formula to solve for it. That's it in terms of notes. So let's see if I can. All right. Okay. I think I've got the right stuff here. With something like 8xy squared plus 16xy over 4xy, a lot of what this comes down to is factoring. What exists in every single term? Well, let's talk about what terms we have. What's one of the terms in this literal equation? Anybody identify a set in here? We're on number 1. I'll give you a hint. 8xy squared would be one term. What else is it? What's another term? 16xy and 4xy. Okay? So what I want to know is what exists. What do all three of those have in common? They all have an x and a y in terms of the variables, right? What do they have in common number-wise? They're all even. And what number will go into all of them? 4. So I can take out a 4, correct? So if I took out a 4, right? Let's see. If we took a 4 out of 8x, what is left? We're left with 2. All right. And you also said that we could take out an xy, right? 4xy goes into all of those things. So now we're looking at division. So 4xy or 8xy squared divided by 4xy. Well, what's 8 divided by 4? 2. And xy squared divided by xy is only going to leave me with what? Actually, the x gets rid of the x, right? And so we're only left with one y. Okay? All right, now let's look at the 16. What's 16 divided by 4? Okay, so 4. And xy divided by xy, those xy's cancel out. Okay? All right. And what's 4 divided by 4? 1, right? And xy divided by xy, those xy's cancel out. So I'm left with 4xy times 2y plus 4. This would just be all over 1. Okay? And if I have a fraction that's written over 1, do I need to include the 1 in the denominator? Yes or no? No. So what I'm left with is that after the 4xy has been factored out, I just have 2y plus 4. Make sure that I've got. All right, let's look down here at the bottom and see if I'm correct. It'd be really embarrassing if I wasn't. Okay, I think they said they got A, and A was our answer. Okay, hopefully that makes some sense. And it's a little different than some of these other ones because they actually have an equal and it's equal to something and there's some moving back and forth, and this was actually factorization. Okay, let's look at number 2. It says solve for p. We have 7p minus 4q equals 9. We want to solve for p. If we're solving for a variable, that means I have to, number 1, I have to isolate that variable. Isolating means to move everything else to the other side. Okay? So, let's, I'm going to rewrite this over here. We have 7p minus 4q equals 9. All right, well, what's the first thing that we can move to the other side, Christian? We just want to solve for p. P is on the left, which means I'm going to move everything I can to the right, but I got to do it step by step. What do you want to move? We have 7p minus 4q equals 9. 4q, how do you move it to the other side? Add it. And the reason why we add is because it does away with it on the left-hand side. Negative 4q plus 4q cancels out, right? It just doesn't change the value. So we call that the addition property of equality, right? And we'll go ahead and we'll rewrite this as 7p equals 4q plus 9. Does that make sense? All right. What else needs to move, Blayton? They didn't ask me what does 7p equal. They said what does p equal, right? Well, what's left to be moved? Well, we just want to solve for p, so we want to leave p there. The 7. How do I get rid of the 7? How do I move it to the other side? Okay, so what's happening? What's 7 and the p doing? They're multiplying. How do I undo multiplication? Through division, right? So we're going to divide by 7 on both sides. So p equals 4q plus 9 divided by 7, right? You could also split it up, and I think that that's what they do here. They showed us p equals 4 over 7q plus 9/7. It's the same thing. Did we see that there? Okay. You pick a variable, you move everything else over to the other side, starting with addition, subtraction, ending with multiplication and division. All right, Jeremy. We got y equals WP. We want to solve this for W. So what do I have to do first? Okay, well, if I want to solve for W, let's first find out where it is. It's right here, correct? Right? And so rule number 1 is isolate the variable. Okay, well, what's with the variable that's causing it to not be isolated right now? P, right? What's W and P doing? They're multiplying. So how do I undo that multiplication? By P. Okay, so we're going to divide by P over here and over here. So what does W equal? Y divided by P. Okay? I mean, if I knew what Ms. Dotson did or what she taught you, I would certainly bring that up again, you know, and have you just do the same thing, but without knowing exactly what it is that we're getting at. I can't reinforce what I'm not sure of. So, okay. So the best I can tell you is isolate the variable, right? Use inverse operations to isolate the variable. Okay, let's see, Tiffany, number 4. We have 3.8y plus 4/7 x plus 2 equals 0, and we want to solve this for y. What's the first thing that you want to move to the other side? And how do we move it? So we subtract 2. All right, so we got 3.8y plus 4/7 x equals what? Equals what? But what did you do here? You subtracted 2 on both sides, right? Equals -2. That's important, right? And the mistake that we make verbally there is the same mistake that we'll make on a test. And will we be right or wrong? We'll be wrong because we didn't do I'm not picking on you. I'm just saying that we would make that recording error. Okay, we need to be careful of it. Let's see, Fraser, what would you do next? Trying to solve for y. Subtract 4/7 x, very good, minus 4/7 x. Okay, so let's see. What are we going to write then? We've got 3.8y equals what? Perfect. -4/7 x minus 2. Okay, so that's simplified up to that point. All right. Let's see. That's a 3.8y, and it looks like 3.8, or it's 3 minus 8y. All right. What's next, McEwen? Well, we had to subtract 4/7 x to get it over to that side. So adding 4/7 x to both sides is going to undo a step we've already done. Keep in mind, what is it that we're trying to isolate? What are we trying to keep by itself? Y. What is keeping y from being alone? Divide by 3.8, right? Okay. Okay, so we're going to get y equals, all right, now we're going to take, and this may take a little bit of an effort, -4/7 divided by 3.8. And it looks like we're going to end up with a fraction there. All right, I'm going to go ahead and pull up the calculator just so you can see this being done. Okay. Okay, we've got -4 divided by 7. Okay, and I keep that in parentheses because I want this to be done specifically. Divided by 3.8. And I'm going to hit math fraction. That's going to give me -20 over 133. X. And then I've got -2 divided by 3.8. That's a little bit easier to do. Okay, math fraction minus 10 over 19. Okay, do we follow that? Okay, all right, I think that's about as much time as we've got because I want to get you guys started. Hopefully we have an understanding, right? We know what we need to do. Okay, find out which variable it is that you're wanting to solve for and move everything else over to the other side. Be really careful. Record your work. Okay? All right.